Hello and welcome to Temperature Controls. My name is Benjamin Heyer. Here's my contact information. You can email me here. This is my office number. My office times are 11 to 2:30 on Mondays, and then Tuesday from 11:30 to 12:30. I'm always available. Call me, text me. I can pretty much make about anything work. Here's my cell phone, so feel free to reach out. This is a 3-credit class. We will be meeting starting the 10th of January and ending April 18th. This class is every Tuesday from 12:40 to 5:10. I would highly recommend you come to this class. It's all hands-on, either testing or working on the computer. We don't have any textbooks required for this class. You do have to go through the motors controls course to become in here. We will need a good multimeter for this class that can read AC and DC. We'll be doing some troubleshooting, testing. Safety glasses are always required on the labs. Basically, we're going to go through and learn about controls, temperature systems, how we can control a building. There's a lot to it, so we'll dig more into it in each class. The grade scale, 90 to 100 is an A, 80 to 89 is a B, 70 to 79 is a C. Anything below that is a D. Basically, you need a 70% or higher to pass. So, attendance, like I said, very good to show up. If you guys are having issues getting here, or you're sick, or you got sick kids or whatever, just reach out. That's all I'm asking. Like I said, my phone's always available. Text, call, email. If you call my office and leave a voicemail, it will get forwarded to me, so I get an audio version of the voicemail right to my email. But here's a quick rundown of our lab. We're going to be adding a lot to this in this class. This is basically our air handler in our lab. As you can see, we got a return fan, supply fan, hot water coil, chilled water coil. We're seeing how much CFM we bring in from outside air, temp and humidity, outdoor air dampeners, exhaust air dampeners, return air temp. And then this particular system, we're trying to maintain a static pressure in the duct. So here's our static pressure sensor. So when we're looking at this is just basically the graphics of the program that we have. Now when we start actually looking at building the stuff, this is what we're going to be building. The graphics come after we do the logic. We have to have the brains behind why we're doing this. So as you can see, there's a lot of ands or ors or the outdoor sensors. So analog inputs, binary inputs, binary outputs, and then analog outputs. So we learn those. Those are the biggest things that control our system. So analog in, this is a variable number, so it could be temperature, percentage, humidity. It's going to come in as an analog. Where a binary in is going to be an on-off signal typically. Same thing with the BOs. So binary out, we're basically this one right here, supply fan start stop. Simple. This binary input, we're seeing that the fan is on. It's an on-off signal. The duct static is an analog input. So we can see that it's going to change from this particular one could be a 0 or a 1. Supply fan VFD AO, so it's an analog out. So we're actually sending a signal from this control program to control the fan speed, which is really cool. And this whole logic right here is basically how that fan maintains a constant static pressure. Here we're trying to control a static discharge set point, so we're trying to maintain 70 degrees, all depending on what we're going through. So there's all these basically we're looking at the outdoor air temperature. We can see we're going from 50 to 100 or negative 15. That's going to change the output of that. So these are converter blocks, linear converters. So we'll learn more about this in class, but I figured I'd just kind of show you guys before we even walk into the classroom. You guys will understand just a little bit of it. So here's some more of our analog inputs. We got supply air temp, mixed air temp, return air temp. So for our whole lab, this is our floor pan. So I can actually, there's that air handler we were just looking at, right? So I'm going to go back one. Here's the furnace room. So we have VAVs in each of those rooms. VAV is a variable airflow. So we got air coming from the air handler coming into this dampener. And that's going to open and close to meet that CFM set point. So there'll be a dampener rod sticking out of the side, and most of those VAV controllers will have an actuator built onto them so they can control that. Here's our hot water coil. As you can see right now, it's calling for 100% open. So we're going to send summer's, on-off signals, summer modulating signals. So we may send it 0 to 10 volts to control this hot water coil. So we can fully close it, fully open it, put it at 50%, things like that. There's some pulse ones out there. Just something we'll get to see a lot of. Supply air temps probably pulling off that air handler, and then the temp leaving the VAV boxes on the opposite side. These here are room zone temps. You're going to see them all over the building. Western Campus uses web control for everything. So the whole entire campus is on this, and I'll bring that up here shortly where we can see everything. So now that you saw just our HVAC lab, I was able to log into our whole campus-wide system. So each of these campuses, I can click on any one of these and pull them up and look at them. So I'm just going to start with La Crosse campus, just because that's where we all are. Here we got the Diesel Annex Automotive out here, Health Science Building. Here is our, actually it says right over here, the Apprenticeship Program Building. Here is our Administration Building. Number 10, we're in Integrated Tech. You can see 11 is the CUM Building. 12 is Lunda Center, 6 is the Coleman, 16 is like the library area, here's the business building, 15 is the dorms, 13 is the parking ramp, 14 is the physical plant, 17 is more like the welcome center, 9 is the greenhouse over here. So I mean, this is really cool stuff when you get to learn it and play around with it a little bit more. As you can see, we got the whole thing laid out here. So I can click on any one of these. Now when we're looking here, we can quickly see, do we have alarm, cool, or ideal? As you can see, we have a big mix of different rooms here. So I'm just going to click on this one. This is the welding lab. I already know that. Fabrication. They're opening the doors. They got a lot of exhaust fans running. You can see we're trying to keep that thing warm. It just can't quite keep it that warm. So if we go back a little bit here, and let's look here. So 4th floor, this is where things get really interesting. This is a really cool unit, and this is what I really want to show you guys. We can build this program. It looks very complicated, but once you start actually laying out the logic, it makes it a lot easier. So we're backnetting a lot of points on this one. When I mean backnetting, it basically we're pulling points from different units or certain suppliers. Like here, multi-stack is one of them. Carrier does it. Train does it. Basically, these come straight from the unit. We can talk to that unit and make program change, or not program changes, but pull points off of that equipment when they already have a supplier temperature or fan status. We can pull all that right off of there. So kind of cool areas. to do. It may not look like a lot to you right now, but once we start actually running through this stuff, you're going to realize, oh wow, this is pretty cool. So definitely something you want to definitely learn. Here we'll click in the greenhouse building. So you can see that they're trying to maintain certain, they're looking at CO levels out there as well. Diesel is going to have a lot of exhaust fans, multiple exhaust fans, in-floor heat, so they're controlling that with it. It doesn't look like in-floor heat when I clicked on it though, so let's go back. Radiant in-floor heat. I must have clicked on the wrong one. So we got some in-floor heat here. We're pushing out 78 degrees, bringing it back, or sorry, pushing out 79, bringing it back at 86. So cool stuff. We've got our boilers here running basically. 2 boilers. Most buildings will have at least 2. That way you've got something to fall back onto if it breaks. We do a lead lag pump for the pumps. There should be a lead lag for the boilers as well. Yep, right here. So we got lead lag for the boilers. We're going to go through and teach you how to make this. Make this whole entire program basically by the time we're said and done. So we'll start off simple. Let me see if I can find a small easy one. Exhaust fans are usually pretty typical. Yeah, so we got occupied. So basically we're throwing an outdoor, this is an analog input, so I should say analog network input. So we're pulling this from one of the other controllers. And actually what's really cool is you can click on them and it'll tell you exactly where it's coming from. So if we click in the details, for some reason we need to find where this was coming from. So it's got an outdoor conditions here. So we're pulling that 39 degrees for today from that position. And then you always want to check your errors. Make sure there's none of those. Run conditions, basically we're running off of a schedule. So when we go through and pick buildings, we're going to want schedules. Basically, so we're telling it to run anytime it's occupied. So we're telling that thing to run, right? So BO, that's a binary output. So it's basically just closing a set of contacts. So now we have probably either amp probe or something like that where we're picking up status here, just on-off status, binary input, right? So that binary input's coming into this proof. Basically, if both of these are on, it's not going to go off an alarm. If for some reason the DO is on and the input's not on, then it's going to trip this alarm and send out notifications for everybody. So basically maintenance and stuff, we'd get a email saying that, oh, this is active, needs to be an alarm. So somebody needs to take a look at it. So if we go back to campus here, let's look at the parking ramp. What in the world would we need over there? Well, we control our lighting. We check on elevator room, IT room, janitor room, sub pump. A lot of stuff we can use this for. Just basically checking things, making sure everything's all right. Here's lighting for the diesel plant. I mean, there's Coleman, the Cum building is pretty cool. If we go down to the first floor where the the food court is here, we can go in and look at these makeup air units. And it's all kinds of different stuff on here. So basically we're bringing in outside air. We got 1, 2, 3 burners to try to make up heat there. So, and it looks like it's an alarm right now for code 57. Sorry about that. And so we'll look around here. I mean, there's quite a few different things we can look at. Boilers. But we will definitely get more and more into this as we're going through the course. Feel free to reach out in the meantime to ask questions. But welcome to Temperature Controls. Just getting into the start of it.